Hello and welcome back to DIY Life. We're back on board the Steve Irwin. We're going to do some maintenance on the backup batteries for the emergency lighting system. If you haven't already, please like, share, subscribe, hit that notification bell icon. So the batteries were sitting for around about 5 or so years, not being charged, and there was a faulty one. These were the maintenance-free gel type of batteries, but yeah, one of them was faulty. One or two of them were faulty, so when you replace one or two, you replace them all. And Kerry's gone ahead and bought some. And the battery supplier supplied some flooded lead acid batteries. They're not maintenance free, but they're very dependable. I like them. Just got to keep up the electrolyte, the distilled water to them. And also, I actually would have liked to have uploaded a different video than this one, just because I wanted to mix it up a bit. Because the last video was, discovering different things about the ship. But I actually, a couple of weeks ago, came onto the ship and we started up and clutched in like we've done before, but we actually ran the main engines for quite a while, a couple of hours, to really heat them up, warm them up. And I would have loved to have done that video, but the process with shooting, filming and stuff like that, getting all the data, putting it into the laptop and everything, and editing, which I don't mind doing. I quite like it, editing videos. Sometimes you misplace the files, which I have done. I've shot with 3 different phones and 1 GoPro and many different micro SD cards. It's somewhere on, and I've got 2 different laptops, so it's somewhere on one of my phones or the memory cards, but I don't have some of the phones with me right now. I'm actually on a ship right now, so it's in my off time. It's good to edit videos, but I really thought I had those files, which unfortunately I don't. So apologies. This video would have come up in the sequence anyway. It's just obviously I wanted to do a video on running and engineering operationally, so that will come up. It will come very soon. And also I have been to the ship even more recently and run up all the machinery again and done some more testing, but also I've compiled a video of the complete startup of the entire ship, ready to leave for sea from Black Ship. So from shore power, starting up the alternator and bringing everything online, like the entire engine room. So that's an extensive video. That's going to be series 1 of that, because I'm sure there will be some little changes, but for now it will be a very good video for anyone to watch, even if you're not going to volunteer on the ship, you can still know about it. But also the people who say, oh, I'd love to volunteer on the ship, will have a look at this video of the entire startup of the ship, and you could watch that before you come to the ship, and then you'll have so much more knowledge. So I did that, and that's going to be coming up as well. So yeah, it's just a process. I would have liked to had a certain other video up now, but this is what we got now, so let's have a look. So I didn't actually take these batteries out, so I'm just working out which cables and terminals go where. So they are 4 6-volt batteries, so we want 24 volt. So obviously I'm going to put them in a series, so it adds all the voltages together to make 24. They are very heavy, and I'm straddling the prop shaft in my crux, just trying to get the batteries safely into the battery compartment. I don't want to drop them into the bilge, and also don't want to strain my back. So just slowly doing that. There's a very good battery lifting strap, which was off the old batteries actually, but must be universal, thank God. Now, on my previous video where it was Black Ship Startup, the pure sound one, I had many comments voicing the opinions of why in the hell did you not have any emergency lighting activated when you were doing that, because that's not right. The ship should have that. Well, this is exactly why I'm doing this right now, replacing these batteries, which are for the emergency backup lighting system, which obviously is running off 24 volts. So these batteries are always charged and always topped up whilst the ship has regular electrical power. So on the bridge there's also backup battery supply for its own 24 volt backup lighting system, emergency lighting. And what it has is a solenoid which is sensitive to the ship's electricity. So the solenoid is always open circuit for supplying the 24 volt emergency lighting system until the 240 volt is no longer there anymore. Then that breaker is going to, I believe it would be spring close the breaker. There must be a 240 solenoid which always keeps the breaker open. So anyway, once you lose 240 power, then it closes that 24 volt breaker to allow the electrons, the 24 volt, to flow through all the emergency lighting system. So this is what that is, the bridge, and we've got this another system in the engine room which should be doing the same thing. I haven't put my eyes on the changeover solenoid like on the bridge that's for the engine room, so that's something I've got to work out. But for now I'm installing these batteries in the correct sequence with the correct terminals, just to make sure it's all going to be working, and then I can go ahead and look for the 240 changeover switch. So one DIY life tip I should have actually used when utilizing terminals and things over batteries, because they can explode, because what the batteries do, they produce hydrogen. The way they produce electrons, they crack the water into its different parts, and hydrogen is one of their parts. So you have a flammable gas near your terminals, and you might accidentally put the shifter or the spanner across, positive and negative, and you have maximum electron flow with maximum current, and it'll spark and arc out, and if you've got enough hydrogen there, it will explode. And my dad's got a story way back when the batteries used to have marbles in them, apparently. He had one blow up, missed his face, but put holes in the garage roof. So what you can do is, your shifter or spanner, whatever you're using, is you wrap it in electrical insulation tape. So I'm realizing this again after the fact whilst I'm editing, but it's a very good tip. I am being careful with this shifter, and they are 6 volt batteries, but still it would have been good to have done that. But irregardless, moving on. So while I'm hooking the terminals up, I might just talk about the lead acid batteries, why I like them so much. There are advantages and disadvantages to them, but they're the ones I do go for when it's, although this ship is moving, when it's in a, not a race application, it's not moving around too much. I like them. The advantages are the reliable and well-tested technology, high surge current capability, great for starting engines, Low cost compared to lithium batteries. Recyclable materials, lead and acid. The disadvantages of them: heavy and bulky compared to modern battery tech. Limited lifespan, 3 to 5 years in typical use, although I have had some lead acid batteries last a lot longer than that. Keep the electrolyte up to them, like the distilled water, keep that topped up and you shouldn't have any problems. Keep charging them. They can leak acid or produce gas if overcharged, like I was talking about before, hydrogen. They're a bit slower charging compared to lithium batteries, but this ship is a 1975 model, so I'm happy to have these style of batteries. So that's all good. So what's inside a lead acid battery, how is it made and all that kind of stuff, and how does it work? Well, there's a positive plate, which is lead dioxide, and a negative plate, which is sponge lead. These are the anode and cathode, where the electrons flow. The electrolyte is sulfuric acid, which is the liquid sulfuric acid, and there are separators separating the two plates, the anode and cathode, positive and negative, which is plastic. Actually, is it plastic? I'm not too sure. But the case is plastic. The separators are non-conductive. And each cell on each battery is usually 2.1 volts. So we've got 3 cells on these, making 6.3 volts or 6 volts. So how does it work? When the battery is used, a chemical reaction happens between the lead plates and the sulfuric acid. Electricity is created as electrons move between the plates. So the sulfuric acid gets weaker, turning it more into water, diluting it. Lead sulfate forms on both plates. Over time, if the battery is not recharged, the sulfate builds up, reducing the performance of the battery. Surely you've had that happen to you. I've had it happen to me a lot. So how do you charge it and what happens? This is basically reversing the process. When you recharge the battery, electricity forces the reaction to go backwards. Lead sulfate turns back into lead dioxide and sponge lead. Sulfuric acid becomes strong again. It goes back into solution. If overcharged though, water can break into hydrogen and oxygen gas, which may escape, and both are highly flammable. Now with lead acid batteries you can get some that are maintenance free or thereabouts. So the one I've got is a FLA, which is a flooded lead acid battery, which needs water refills. You generally use demineralized water, or what's the other name for it? Distilled water. But you can also get them in a sealed type. And with the sealed type, there are a few different types. SLA, sealed lead acid battery, and VRLA, valve regulated lead acid battery. This refers to the same thing, a type of lead acid battery that doesn't require adding water. The VRLA, valve regulated lead acid battery, simply means the battery has a pressure relief valve to prevent gas buildup. Therefore, these type of batteries are safer and maintenance free, making them popular for UPS systems, which are uninterruptible power supply systems, motorcycles, solar storage and medical devices, and emergency backup lighting batteries, like we have here. Now, the AGM, the absorbent glass matte batteries, is also a type of sealed lead acid valve regulated battery, where the electrolyte is absorbed into a glass fiber mat, preventing spills and making it more vibration resistant. The pros of an AGM: spill proof and maintenance free, charges faster than a standard lead acid. They handle high power demand well, great for start-stop car systems, and performs well in cold weather, believe it or not. The cons of AGM batteries: they're more expensive than flooded lead acid batteries, and also can be damaged if they're overcharged. I certainly have done that, and I believe that's when the AGMs, they swell. So yeah, you gotta be wary of that. So I guess you can see with this long form video, just see how, time consuming even just this small job is, especially when, I wasn't the one who removed them. Just finding the terminals and the cables and making sure I'm doing the correct sequence of wiring them up, but I think I've got it all sorted out pretty good. So I'm just continuing with that, and just putting the pieces of the puzzle back together. But it'll be great to test these emergency lights with the next power outage. But I will have to find that 240 changeover solenoid. I know where the one is on the bridge, but yet to find the one in the engine room, but that's a must. Also, what I think these batteries could be is 24 volt control voltage for main engine interlock switches and things like that, and also the buttons that we press to clutch in, which aren't working. I think maybe they could be on this circuit, so I'm hoping that that's going to help fix that problem once these batteries are in and charging and doing their thing. But it could be totally separate, but it's just me hoping and wishing. So I'm just about to connect the last cable up, so I'm just going to tap it really quickly, make sure there's not a lot of arcing, which is having it connected up wrong. It's going to have full current. So that didn't spark, so that was good. So I'm safe to connect it and do it up. And then I'll just make sure the batteries are mounted properly, and there's spacer bars in there, bits of timber spacer. I'll fit in there and clean the area up a bit, and make sure the cables are coming into the battery box safely. They're not going to rub on each other. All essential things, because once you put these in the battery box, like, the box will be open to top up the batteries, but over time there's a lot of vibrations on the ship, so you're going to make sure that nothing's going to vibrate and slowly rub through maybe a positive to a negative, or positive to earth, or something like that. So these are the things you've got to check. So I'm just trying to get the batteries nice and snug in there. And in actual fact, you could have had bigger batteries in there. Obviously the battery box is a lot bigger, but we've gone with these. We've had these in the past and they've done the job. But I'm noticing the small bits of timber, which are the end spaces for where the cables come in to push the batteries back a bit. So obviously realizing this now, so I'm going to have to pull them back and fit these small timber spaces in both sides, and then have a look at the cables, make sure they're not going to rub. This is the ever-present thing with fixing anything mechanical. You could do the whole job and be on the last step and realize, oh no, I forgot to put this in, and have to remove everything. Luckily I could push that bit of timber through, but it's just a massive thing that you've got to do sometimes. You spend all this time repairing something, putting it all back together, and you're like, I forgot to fit that circlip or that bolt, and you just got to pull it all back into bits. So that's a constant struggle sometimes with engineering and mechanical stuff, but yeah, regular people that don't do any of this don't realize that. So yeah, anyway, that's just my little vent for for the day. Well, they're all fitted, so I'm gonna head up, check the charger and check the amps that are going into it and the voltage and everything like that, to make sure it's all hooked up properly and the chargers operating correctly, plus the batteries are taking the charge. And once you turn a battery charger on, it should go to a certain amperage of charging current, and then slowly get less and less and less. So I'll just check that. Here's another tight squeeze spot on the ship, but I'm already on the correct side, so it's a little shortcut. Just got to squeeze in there. So I'm just going to check the overall voltage across the two terminals that go out from the batteries that are connected in series, making 24 volts. So I'm going to check that voltage now. How's that looking? It's looking good, 24.8. And what I want to do is leave those connected, the multimeter connected with its terminals, switch the charger on, run down and double check that the voltage is actually going into the batteries from the charger. So here we are with the 24 volt battery charger. I'm just going to close that cabinet up and get it online. So one thing you certainly have on a ship when you're working on it is a lot of steps per day and a lot of stairs per day. I find it interesting, the different machines at certain gyms, like treadmills kind of seem a little bit odd, but those stair machines, man, they just continually have stairs like rolling over, and you got to keep stepping up the stairs. It's like that working on a ship. And if you can see just on this one video, I'm going up and down a fair few times, so it is a good thing. It keeps you a bit fit. And that brake kept flipping out, and I had to reset it 2 times, so it's finally taken now. You can see some of the fuses missing, so I've got to find the fuse holders for those to complete their 24 volt emergency lighting circuitry.
Slowly. Come through.
So that's just what happens when a ship's sat around for 5 years. There's a few different fuses laying around here and there. I remember that I was told there could be some spare fuses on the bridge, so I will have a look at that to try and complete that fuse panel for the 24 volt emergency lighting system. But for now, I will be checking the charger is, charging. So straight back down to the charger. Make sure it's got at least probably about 27 volts or thereabouts when it's charging. You want to see the ammeter, or the current flowing into the batteries, to be at a value greater than 0. I think my light's a bit bright to see the figure on this meter. I can zoom in with the phone so you can see it a bit better, and I took a photo with the time just so I can check that it is actually diminishing in charging current. Back down the little squeezy bit, and having a look at the multimeter to see what voltage we've got. 27, I believe. 27, yeah, 27 volts going into those batteries. That's excellent. So I can remove that and just make a maintenance schedule to top these batteries up every week. Just pull those caps off and then get the demineralized or distilled water into a little canister. And there's auto ones that you can have where you just put the nozzle on them, push down, and they fill up to a certain point. That is super quick and easy. So that's all looking good. Well, actually I did notice some of the negative and positive wires were rubbing, so I'm just trying to realign them. Just bend the copper a little bit just so they're not touching ever, just to eliminate them slowly rubbing together and causing a fire or damage. So that's just something you got to check, got to do. Well, that's looking pretty good now. I'll just head up to the battery charger and just check the charging current, the amps are diminishing, and that'll prove that the electrons are flowing into the battery and reversing the process of discharging like I explained earlier. So that's cool. I can see the amps have dropped off a bit, so the batteries are taking a charge. That's all looking good. Successful job. But now what I want to do is oh yeah, you can see it zoomed in there. Yeah, that's about 7.5 amps on the first charge. Now let's look at the amp meter now, what it's sitting at. See, it's below that 7.5 line. It's more closer to about 6 or 5 amps. So that's looking great. Yeah, that was original. That's 7.5. So that's good. It has dropped and working well. Just venturing up to the bridge. The red light there is the light that they use when they're navigating at night, so their eyes don't get too badly adjusted to the white light when they're walking up to the bridge, and also it doesn't shine into the bridge, and if it does, it's just a red light. So I'm just checking here up on the bridge because I'd heard that there were some fuse holders and fuses floating around. Looks like I found some. That's cool. That's going to help me out to fill up all those spots on that lower 24 volt emergency lighting distribution fuse panel board. I'll have to test these fuses and reinstate them. So I'm back in the ECR, engine control room. Just want to test these fuses for continuity. You can use ohms resistance. I just kind of like continuity because you get a solid beep when there is connection. So there's a lot of them that are no good, so I'll have to order some. But this is the process we do, especially when a ship's been laid up for 5-6 years. It's a necessary evil. So it does look like every single fuse is blown except one of them. So I'll just have to see if I can find them on the ship. If not, order them. That'll take a little bit of time, but just what you gotta do. Well, that's pretty much going to wrap up this video. I do promise to share and upload the video that I really wanted to of warming up the entire ship and the trials and tribulations of doing that. Please, if you haven't liked, shared, subscribed, please do that now. And I look forward to seeing you guys and chatting with you in the next one. Bye for now.